Hello and welcome into the content video for lesson 14 for Precalculus 2. This lesson is about polar graphs, and specifically for the purpose of this class, we're just going to look at three figures generated by different polar equations. So if you are in my class, or in one of my classes, I guess, on the main page, you will find something called polar graph shortcuts. I'm going to put it on the screen here so you guys can see it. So if you are not in my class and you happen to be watching these videos to try to get a better understanding of the polar graphs, I'll try to maybe zoom in and leave it there for a second. You could always do a screenshot, something like that. So we have three different types of polar graphs that we're going to be talking about. The first one is what's called a cardioid. And so, as the name sounds like, it's a heart. The second one is a limacon with an inner, excuse me, with an inner loop. And then lastly is what's called roses. I'm going to be totally honest with you. They look more like daisies to me than roses, but someone a long time ago, way above my pay grade, decided to call them roses, so that's what we'll stick with. Now, again, for the purpose of this class, we're not going to be so concerned with actually sketching them. Rather, I want you to be able to identify, based on the equation, what type of figure is it? Is it a cardioid? Is it a limacon with an inner loop? Is it a rose? So if we go back to the cardioid, the format of the equation is going to be R equals A plus or minus, excuse me, the same value A and sine of theta, or A plus or minus that same value A cosine of theta. So that's what we are looking for here. If these guys are the same, whether it's plus or minus doesn't matter, but if it's the same numerical value, that tells us this is a cardioid. All right, fine, it's a cardioid. Now, in terms of if it's pointing up, down, left, right, or facing up, down, left, right, depending on which book you use or which instructor you might have. So cosine is always going to be left and right. So cosine is our x value, right? When we're doing a unit circle. And so x value is the horizontal axis, so that's left or right. If it's a plus in between, then it means that it's facing or pointing to the right. If it's a minus in between these numbers, then it's facing or pointing to the left. And sine is my y value, so it's the y-axis. Oh, yeah, so here's sine, cosine. But if it's sine function, that's my y value, so that's going to be up or down. And as you would think, if it's a plus, it's facing up. If it's a minus, it's pointing down. The tip, or the furthest point of this heart, of this cardioid, is 2 times A units away from the origin. The sides of the heart are A units away from the origin, and we always include the origin as a point. So for what happened? What's going on here? What is this doing? Okay, that was weird. So let's say that I have as an example, let's do 2 plus 2 cosine theta. All right, I see they're both 2's. I know it's a cardioid. I know it's going to look like a heart. Cosine, x-axis, so that means it's going left or right. And because it's plus, it means it's pointing facing to the right. So the furthest point away is going to be out to the right. Now, where is that point? Well, my A in both of these cases is 2. So the tip is 2 times whatever my A value is. So 2 times 2 is 4, meaning the tip of this heart is 4 units away to the right. So because this thing is pointing to the right, the sides are now actually moving up and down because this heart is turned sideways. They're A units away, so 2 units away. And then again, I always have the origin as a point. So this is not like in second grade when you wrote a heart to your sweetheart and you made it real pointy like that. This is coming from the unit circle. And if you plotted all these points, theta is 0, theta is pi over 2, theta is pi, theta is 3 pi over 2, theta is 2 pi, etc. It's going to create this curve that comes around in a nice smooth fashion. And the only place we have the point is right there at the origin. So that is a cardioid pointing to the right. And that's what you would have to know here. You'd be given something like this equation on a test and say, okay, well, they're equal. So I know it's a cardioid. Cosine is left or right. And because of the plus sign, it means it's a cardioid pointing to the right. That's all you're going to really need to know. You're not going to have to identify pictures. You will on WebAssign, you will on the homework, because that's kind of how the system is set up. But again, if you know it's a cardioid pointing to the right, there's probably only going to be one of the 4 choices. It looks like that. The limacon is essentially a cardioid with an inner loop. So all the same stuff sort of applies. Cosine is left, right, sine is up, down. The tip, so the difference here is that A and B are not equal now, and A is actually less than B. So say, for example, I have something like 2, so this is going to be R equals. So R equals 2, let's do minus 3 sine theta. So the numbers are different. So therefore, I know it's a limacon with an inner loop. The tip is A plus B. So my A is 2, my B is 3. The minus sign is just telling me which direction. It's not like this is a -3. So it's not like, oh, A plus -3 is -1. No, 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 no. A is 2, B is 3. So therefore, in this case, the tip is going to be 2 plus 3 units away, or 5 units. Why is this? I don't. Hopefully, this isn't popping up on your guys' end. I don't know why my Windows system keeps popping up here. Sorry. The sides are still A units away, and the A is the first number, so 2 units away. The inner loop, so it's going to look like a heart with a hole in it, is B minus A. So my B is 3, my A is 2, so the loop has a distance 1 unit away from the origin, and again, we still have the origin. So if I was to draw this picture, okay, they're different. It's a limacon. Sine is up, down, and because of the minus sign means it's pointing down. So the tip, the furthest point away, is 5 units. So down here on the y-axis. The sides are 2 units away. So here and here. The loop is 1 unit. So because it's going to be inside, I move down as well. And then please do not forget the origin, because what happens here is that people forget to do the origin and then they make just basically a funny looking cardioid. So we have a inner loop, we have a circle here that then continues on to essentially make another cardioid. So that's what this equation, what kind of picture it would generate. It's a limacon because the numbers are different, pointing down because its sign is up or down, and the minus tells me it's pointing down. And then lastly, for the roses, you'll notice with these, there's no plus or minus. So that's how you can distinguish right away that, oh, this is the graph of a rose. The length of the leaves, so how long each leaf is A units, whatever number's in front of this trig function. The number of leaves depends on the value that is in front of the theta. If n is odd, then it's just n leaves. So for example, if I have r equals 2 sine of 3 theta, well, the number in front of theta is odd, so this means there are 3 leaves. If I had r equals 5 cosine of 6 theta, well, 6 is even. If n is even, it's double that number. So in this case, this would actually have 12 leaves. 6 times 2. The degrees between each leaf is just 360 divided by however many leaves we have. So if I have 3 leaves, 360 divided by 3 is 120 degrees between each leaf. They're all uniformly distance apart. And then the key is, where does the first leaf start? So for a cosine graph, the first leaf always starts at 0 degrees. So that's what? That's over here. I'm always going to have a leaf off to the right. So if I had 3 leaves, maybe I have something that looks like this. For sine, the first leaf always starts at pi divided by 2n. So let's say my n is 2. And I have the sine function. The first leaf is pi divided by 2 times n, 2 times 2, or pi over 4. Pi over 4 is up here. And if I have 4 leaves then, because my n is 2, you would get something that looks like that. Like I said, more like a daisy than a rose to me, but who am I? I'm not some florist or flower specialist, So that's it. So that's really what you guys are going to have to know. Based on the equation, tell me, is it a cardioid pointing up, down, left, right? Is it a limacon pointing up, down, left, right? Or is it a rose? And how many leaves does it have? So that's it. That's what you need to know for this. Come on back and we will look at some examples.